Okay, today we're going to get back into our discussion of solids by taking a look at something that you may or may not be familiar with already, and that is volume. I suspect that you have talked about volume of three-dimensional shapes at least on some level somewhere down the line. But as you saw with surface area, since we now have some more advanced shapes than you may have had in junior high, things like regular polygons and stuff like that, that our solids may have some more unique shape to them, and that will change the kind of information that we plug into the formulas. But the formulas should remain from what you remember back in pre-algebra or 7th grade. Okay. Now, basic definition here, volume. Okay. Volume is the amount of stuff that is required to fill a solid. And again, stuff is my highly technical term. But as I told you at the beginning of our discussions on surface area, if you think about a birthday present or a Christmas present, surface area is the wrapping paper, volume is the present itself. Now, many of the solids that we know have a generic formula that we can use to find their volume. However, the formula is so generic that we do have to adjust it pretty much every single shape that we look at so that it will fit the particular solid that we are looking at. Okay. Now, hopefully you've seen the formula before. It's been all over your formula chart for years, and I do hope that you had a teacher that at least worked with you some on volume somewhere back down the line. The formula for a prism is volume equals big B, little h. Now, a couple of points of refresher here. Okay, we have this word prism. When they say the word prism, what does that mean? It has some rectangles. Yeah, most prisms, they're built out of rectangles. True enough, they are. Okay, whereas pyramids are typically built out of triangles. Okay, but more specifically, prisms, okay, the word prism deals with the bases. Okay, and specifically about the bases, when they say prism, there's two bases. Okay, so that's one of the things we need to know. If they say prism, you're going to need to know that means two bases, because it's entirely possible on these problems, they may not draw you the figure. They may just say, hey, there is a triangular prism, or there is a pentagonal prism, without knowing that a prism is a figure that has two bases. That may lead you to misunderstand the problem, and if you're trying to draw it for yourself, you may misdraw it. Now, on these variables, okay, big B, okay, remember, that's the other thing I was going to ask you before I uncovered this, but anyway, anytime you see a capitalized letter inside of a formula, that particular value is typically referring to something about one of the bases. Okay, in this case, big B represents the area of the base. Little h represents the height of the prism. Okay. All right. So the other day when we were working surface area, we started off with some prisms. We're going to look at the same prisms again, only this time we will calculate volume instead of surface area. Okay, just like with any other problem, okay, any other problem, if a problem comes with a formula, and that formula is what we're going to need in order to solve the problem, then transfer it to your paper, even if it is a simple formula like this one. Okay, volume equals big B, little h. Just a good habit to get into, having your formula and your problem all in one place. You'll get that one off the formula chart. Volume equals big B, little h. We'll worry about it one step at a time. Okay, big B. Okay, big B represents the area of the base. Okay. Well, in order to figure out the area of the base, well, the base is simply a polygon. That polygon, whatever it is going to have its own area formula to calculate its area. Okay, so you better identify correctly what kind of shape your base is. Okay, well, what kind of shape is our base? Rectangle of some kind, right? If you can't tell it by the picture, We have a description up here, rectangular prism. So they did say that, hey, your base is rectangles. Now, on this particular prism, the rectangular prism, okay, remember that bases are simply two parallel congruent sides that are across from each other. Okay, well, look at the rectangular prism. There's more than one place we can say that that's happening, right? Can we say that the top and the bottom are bases? Sure, they're congruent, they're parallel, they're across from each other. Can we say the front and the back are bases? Yeah, you could do that. How about the left and the right? Yeah. So with a rectangular prism, you actually have some options as for what you want to call the bases. Okay, so typically with a rectangular prism, the easiest thing and the least confusing thing to do is just say, hey, it's sitting on one of its bases and the other one's on the top. Okay, so that's probably the least confusing way. So our shape of our base is a rectangle. Okay, and how are we going to find the area of a rectangle? Uh-oh. Length times width, or more specifically, base times height. Okay. Now, guys, you gotta keep this a little bit straight in your head. It's unfortunate. Look what just happened. We have an H in our volume formula. We now have an H in our area of our base formula. Do not confuse the two. Okay. This H that we just discovered, that is the height of the base, not the height of the prism. Okay, so when you're thinking about big B, when you're thinking about the area of the base, think only about the base. What are the base and the height of the base? 4 times 3, right? Okay, the rectangle sitting on the bottom, its dimensions are 4 by 3. Okay, don't get suckered in by that 2 that's up there in the prisms. Not the height of the prism, this is the height of the base. 4 by 3, very easily, that's 12. Okay, now moving on, we get to the little h from the volume big B little h formula. Okay, that h is the height of the prism. Well, how tall was the prism? Okay, 2. And remember, height is not necessarily how tall, it's how far are the bases apart. So if it had been left and right, we'd be measuring how far sideways they're apart from each other. If our bases had been front and back, it would be how far are they apart from each other. Okay, if our bases are on the top and the bottom, then they are, in this case, 2 inches apart from each other. Okay, that puts us in a spot now where we have everything that we need to have. We got big B, we've got little h. How much was the area of the base? It was 12. Yep. And the height we now can see is 2. Very simple calculation. 12 by 2 is 24. Volume is a third dimensional measurement. Okay, so its units of measure will always be cubed. Okay, so we have 24 cubic inches, which is just to say that inside of this box, there are little boxes. They're 1 inch wide, they're 1 inch deep, they're 1 inch tall. Okay, little 1 inch cube. Okay, and there's 24 of them that it would take to fill up that box. Okay, that is as difficult as the problems get. The only thing that changes is the shapes. Okay, different shapes are going to bring us different math. They're going to bring us different formulas, but it all remains the same, big B little h. Okay, so find the volume of the triangular prism shown below. Okay, it's a volume, it's a prism. Okay, we can see that because of the wording in the problem. Okay, so we have a formula. We'll take the formula off the formula chart. We'll put it down on our paper, big B little h. Okay, so let's work with the formula. Big B, what type of a shape is our base this time? Triangle. Okay, it was identified in the problem, triangular prism. Okay, so we have a triangle. How do you find the area of a triangle again? Base times height divided by 2, or 1/2 times the base times the height, absolutely. And of course, again, keep in mind this h that this formula brings to the problem, that is not the height of the prism. That is the height of the base. Okay, so in order to figure out big B, 1/2 times base times height, we need to know the base of the base and the height of the base. What are those measurements? Okay, remember base and height are going to be perpendicular to each other. Okay, it's the 4 and the 3. Okay, So simple enough math on that. Half of 4 is 2, and 2 times 3, 6. Okay, so there's big B, 6. Now we need the little h from the formula, big B, little h. This is the height of the prism, okay? Or more specifically, how far are the bases apart from each other? They are 6 meters apart from each other. Okay, so how tall is the prism? 6. That's the distance between the bases. And that's all the information that you need. We've got big B. We now have little h. Big B was 6. Little h is 6. 6 times 6 is 36. And as Saul said, it would be cubic meters in the end. So we have 36 meters cubed. All right, the next shape we looked at when we were talking about surface area was a cylinder. Okay, so we definitely want to have a look at this again. If you remember what I told you, they do have the tendency to ask about cylinders and cones a little bit more than the shapes that have polygons on their bases. Okay, so we definitely want to catch this one. And I think what you're going to see here is probably the reason why most people prefer volume calculations as opposed to surface area calculations. With the surface area of prisms, we had to look at the nets in a lot of cases, look at all the individual shapes, figure out all the different measurements of the shapes, calculate all the individual areas, and add them all up. Volume is a little bit more cookie cutter in the fact that we can really kind of get the information to fit the formula over and over again because the formula is so generic. Okay, well, let's have a look here. Again, it is a prism. Okay, we know it's a prism because they called it a cylinder. Cylinder is the fancy name for a prism that just has circular bases. Okay, so big B, little h. So once again, we'll worry about big B. Okay, well, what kind of a shape are our bases here? Circles. Okay, circles. So bases are circles. You answered what kind of shape it was, cylinders. Okay, so we have circular bases. Okay, how do you find the area of a circle? Pi r squared. Yeah. Okay, so we're just going to plug in. The only thing you need to know in order to find the area of a circle is the radius. Okay, how much is our radius? Yep, we got 4 feet on our radius, so we'll be able to plug in 16, or 4 squared will be 16, and then pi, okay, whether you do 3.14 or whether you hit the pi button, whatever the case may be. I got a value that I rounded off to 50.27. Okay, now the height of the prism. Okay, so once again, on height, we're not necessarily asking how tall is it, we're asking how far are the bases apart from each other. Okay, in this case, the bases are on the top and the bottom, so they are 10 units apart from each other, 10 feet apart from each other. So there you go, an easy 10 on that one. And this is why a lot of people like the volume calculations rather than the surface area, because typically with volume, most of the information that you need is already in the picture. There's very little you have to solve for. It's just a matter of identifying it correctly and plugging it in. Okay, so volume equals big B little h. We said the area of the base was in the vicinity of 50.27, and the height we now have at 10 units. Well, multiplying 50.27 times 10 is just going to move the decimal over one spot. So you got 502.7. And since it's volume, we get a third dimensional feet, cubic feet. Okay. Now that was actually the end of the notes when we were going over surface area. But I do want to point out one more thing. I'd like to look at the cube for a moment. And the reason I want to look at the cube is because it is a special type of a problem. And along with special types of problems, sometimes brings a special consideration. Okay. Now the formula is going to remain the same. Volume equals big B little h. Okay. But a lot of questions start to arise on the cube. Okay. First off, where are the bases? Okay. Yeah, what do you think? Yeah, they're all the same. So again, like the rectangular prism, we kind of have free reign to call anything that we want the bases. But then it puts us into a situation. Let's say we treat it like we did the rectangular prism. Let's say we call the bottom and the top the bases, and then we go to try to calculate big B. Well, we don't have any measurements, okay, on the top or on the bottom, or do we? Yeah, and that's where you kind of run into a little bit of a snag. What you need to remember is that a cube has squares for all of its sides. That means its base and its height of its base and the height of the cube are all the same value. All of the edges in a cube are going to be all the same value. Okay. Now, if that's the case, then this 9 mm measurement that we have up there spreads to all of the edges. And when you get to the point when you start to plug into your formula, trying to figure out big B and figure out little h for the volume formula, what you're going to find is you end up with the exact same measurement in all three places. The base of the height, the base of the base, the height of the base, the height of the cube, it's the exact same number each and every time. So actually a little bit of an easier way to think about it, if you're ever asked to find the volume of a cube, it is simply side squared or side cubed. And you're not going to find that formula on a formula chart, would be my guess. Okay, so just remember, okay, that all you have to do is just comes down to volume of a cube. Find one of your edge measurements. The only one we have is that one right there, a 9, and cube it. We're going to get 9 times 9 times 9. Okay, I doubt anybody knows what that is, so I'll just let you know it's 729 cubic millimeters. Anyway, that is it. Okay, you have that one formula over and over again. Volume equals area of the base times the height. Tomorrow we will take a look at the figures that only have one base, but for now you have a worksheet to go along with these.